I myself, A Navin, roll number 49, and my topic is parsing. Definition of parsing. A parser is a compiler or interpreter component that breaks data into smaller elements for easy translation into another language. A parser takes input in the form of a sequence of tokens or program instructions and usually builds a data structure in the form of a parse tree or an abstract syntax tree. Types of parsers. Top down parser, in that backtracking and predictive parser. From bottom up parser, LR parser and shift reduce parser. In LR parser, again SLR, LR and LA, LR. There are basically two types of parsers, top down parser and bottom up parser. Top down parser starts at the root of derivation tree and fills in, picks a production and tries to match the input, may require backtracking. Some grammars are backtrack free predictive. Bottom up parser starts at the leaves and fills in, starts in a state valid for legal first tokens, uses a stack to store both state and sentential forms. Top down parser. A top down parser starts with the root of the parse tree labeled with the start or goal symbol of the grammar. To build a parse, it repeats the following steps until the fringe of the parse tree matches the input string. Step 1. At a node labeled A, select a production A to infinite alpha and construct the appropriate child for each of symbol. Step 2. When a terminal is added to the fringe that does not match the input string, backtrack. Step 3. Find the next node to be expanded. The key is selecting the right production in step 1. Problems with top-down parsing. Backtracking. Backtracking is a technique in which for expansion of non-terminal symbol we choose one alternative and if some mismatch occurs when we try another alternative if any. If for a non-terminal there are multiple production rules beginning with the same input symbol, then to get the correct derivation we need to try all these alternatives. Left recursion. Left recursion is a case when the leftmost non-terminal in a production of a non-terminal is the non-terminal itself. Direct left recursion or through some other non-terminal definitions rewrites to the non-terminal again. Consider these examples. A to AQ direct, A to BQ or B to AR indirect. Left recursion has to be removed if the parser performs top-down parsing. Removing left recursion. To eliminate left recursion, we need to modify the grammar. Let G be a grammar having a production rule with the left recursion A to AA and A to B. Thus, we eliminate left recursion by rewriting the production rule as A to BA dash and A dash to B A capital A dash and A dash to C. Left factoring. Left factoring is removing the common left factor that appears in two productions of the same non-terminal. It is done to avoid backtracing by the parser. Suppose the parser has a look ahead. Consider this example A to QB by QC, where A, B, C are non-terminals and Q is a sentence. In this case, the parser will be confused as to which of the two productions to choose and it might have to be backtrace. After left factoring, the grammar is converted to A to QD and D to B by C. Predictive LL1 parsing. The first L in LL1 refers to the fact that the input is processed from left to right. The second L refers to the fact that LL1 parsing determines a leftmost derivation from the input string. The one in parentheses implies that LL1 parsing uses only one symbol of input to predict the next grammar rule that should be used. The data structures used by LL1 are input buffer and input buffer, stack and parsing table. The construction of Predictive LL1 parser is based on two very important functions, and those are first and follow. For construction of predictive LL1 parser, we have to follow the following steps. Step 1, computed first and follow function. Step 2, construct predictive parsing table using first and follow function. Step 3, parse the input string with the help of predictive parsing table. First, if x is a terminal, then first x is x. If there is a production x gives to alpha, then and sigma to first x. If there is a production x to y1 y2 so on yk, then add y1 first y1 y2 to yk to first x. First y1 y2 up to so on yk is either first y1, or if first y1 does contain sigma, then first y2 is everything in the first as well as everything in first y2 to yk. Follow. First put dollar symbol the end of the input marker and follow. If there is a production a to a capital B and small b, where a can be whole string, then everything in first b except for is explained in follow b. If there is a production a to ab, then everything in follow is in follow b. If there is a production a to abb where first b contains sigma, then everything in follow is in follow b. Bottom up parsing. Bottom up parsing starts from the leaf nodes of a tree and works in upward direction till it reaches the root node. We start from a sentence and then apply production rules in reverse manner in order to reach the start symbol. Hence, here parser tries to identify RHS of production rule and replace it by corresponding LHS. This activity is known as reduction, also known as LR parser, where L means tokens are read from left to right and R means that it constructs rightmost derivative. Shift reduce parsing. Bottom up parsing uses two kinds of action, shift and reduce. Shift, move one place to the right, shift a terminal to the left string. Reduce, apply an inverse production at the right end of the left string. If a to xy is a production, then cbxy by ijk gives cba by ijk. Operator precedence parsing. Operator grammars have the property that no production right side is empty or has two adjacent non-terminals. This property enables the implementation of efficient operator precedence parsers. These parsers rely on the following three precedent relations. These operator precedence relations allow to delimit the handles in the right sensational forms. Marks the left end appears in the interior of the handle and greater than marks the right end. Suppose that dollar is the end of the string, then for all terminals we can write dollar less than b and dollar greater than b greater than dollar. If we remove all non-terminals and place the correct precedence relation between the remaining terminals, there remain strings that can be analyzed by easily developed parser. That's all about my topic. Thank you.